The next part we've got is in life. So we come from a call logging background. We are, some of our largest customers are logging, maybe 1.4, 1.5 million events per month. So it'd be people like police. So huge amount of data. Well, again, what we try and do is make everything point and click. So, we can look at things from a departmental point of view and then drill down and see individual users and, see individual calls that are there, but also capturing, instead of just capturing calls, also capturing things like noise information, background noise information from headsets, building access information, calls. So we're capturing everything here. It isn't just about capturing calls, it's capturing all of the human events within an organization. So it's about people logging rather than system logging. So whilst we have all of the traditional reporting you'd expect there to be there, so greater service reporting and things like that to be able to work out actual utilization of systems over a period of time. Where it gets clever is the way that we can then use that data in a different way. So for instance, I could look at a standard deviation report and I could do things like, so let's compare the help desk against the developers. So we're using the help desk as a standard deviation model to against the developers. So what this is looking at here is it's showing me, first of all, in terms of call durations. There's the standard deviation model. So typically the help desk is 8 minutes 20. But you can see there's some really long durations here for the developers. Well, we'd expect that probably. You can see, the help desk are doing all calls and the developers are probably doing third line support as well. So that's to be expected. But what it's saying here is our time to answer for the developers falls outside the standard deviation model as well. Well, just because they're doing longer calls doesn't mean they shouldn't answer the phone just as. Now, that's a very simplistic view of standard deviation modeling, but here's a different skew on that. After a conversation I had with a government agency's cybersecurity director, he told me that if someone was working for a foreign actor or was being blackmailed or was involved in industrial espionage, their behavior on communications platforms changes ever so slightly. So you get the same sort of answer times, you get the same sort of call durations and the same number of calls, but how they occur changes subtly. So, they might hesitate for a tenth of a second when answering the phone. And a call logger would not pick that up normally because, they're still answering it within 5 seconds. But when you do it as a standard deviation, that starts jumping out. Or they start making calls at different ends of the day because they don't want to be overheard. So you can actually use this as a means to monitor certain people. So you could use it as in cybersecurity and data security to actually compare against themselves. Another way is to use it in a more positive way. You can take the shining person in your contact center, the one who's the leading light and anecdotally works the best, and use them as the standard deviation model to compare against everyone else to see how they're different and why they're different. So looking at different ways. We can also do things like look at information in a sort of timeline. So I could look at particular users and I'll just look to showing all events that we want to see. We can actually see activity over particular days, and I can drill down and see particular events, see exactly what happened at particular times. So I can see individuals' activity at any moment during the day to see what they were up to. I can also look at that as a sort of vertical timeline as well and actually see different things happening at different times of day. So there's calls there, and then there's movement through the building, there's another call, and so on. And when you start getting onto the movement of people, that's when we start looking at things like the property, where I could take that information about people moving around and then start mapping that onto a model. So I could take an office building, take that data, show all the movements of all of the people around a building. So I could actually heat map it and say at different times of the day where people are moving throughout the building. Now, this is real data from some work we did with a large investment bank when they were in their old building by Liverpool Street Station. And the reason they asked us to look at this data was they wanted to know how many people were using the canteen, because they wanted to know whether to subsidise it or not. And we gave them that information. We took the data from the building access system and from the EPOS tills. But here's the interesting thing that we also got from this data. When we looked at it, we found some weird patterns, which was in the morning, everyone was coming in this lower ground entrance. But of an evening, they all went out the first floor entrance. Now, if you're all familiar with the building by Liverpool Street Station, you'll know why that was, because trains will come in at different times. So, of course, everyone comes down the steps here and walks down onto Bishopsgate, goes to Pret, sells their firstborn child so they can afford a coffee and a croissant, and then comes in the lower ground entrance and goes up to their desk. But at 5 o'clock, the only thing on their mind is either rushing out this door to try and desperately get a seat on the train, futile, goal, of course, or rushing left straight into the Witherspoons to get a cheeky pint before they have to go home and face the other half. So, and you might think, well, what use is that information? Imagine now, though, that there is a major incident. Let's say there's a fire or a bomb goes off. Do we think that everyone's going to walk down the stairwells in an orderly fashion looking for the teacher's pet and the high-vis jacket and the clipboard, as they've done in every fire drill? Or do we think they're all going to run screaming down the stairs, running for their lives, going out that door that they're pre-programmed to go out? Because although we think we're high-functioning apex mammals, we're really nothing more than slightly smarter sheep. Neurons that fire together wire together, so that repeated behavior becomes ingrained in our psyche, and we will run screaming out that door we go out of every day. Now, knowing this means that you could perhaps reconfigure the building, change lifts on one side of the building to stop at different floors, or have different doors and different exits for different parts of the building. Because once that behavior becomes ingrained in an emergency, people will behave in a different way. Another way that we're using that information is to do things like track and trace. So, I could say, well, Fred's just phoned in, he's got coronavirus. Who's he come in contact with? Well, there we go. So the same data, I can now correlate that with movements through the building, see exactly where he's been. But also, I can see that Fred's come in contact with Rita and me. But actually, the places where he came in contact with me was just an entrance door and the speed lanes coming into the building and by the west corridor. So, he wasn't in a meeting room with me for more than 20 minutes, so that's not a problem. No, so this is actually pulling information about movement through either card access to different rooms, Wi-Fi access points. So as they walk past the Wi-Fi access point, their phone's beaconing off of it. So we're not using any apps. We're not using, BTLE tracking modules or anything like that. The thing with UCentric is it's all about leveraging data that already exists. Most businesses are sitting on a tsunami of data that they have no idea how to use or how to access or turn into anything qualitative. They've got millions and millions of records and no way of actually turning that into meaningful reporting. And that's what UCentric's all about turning that into meaningful reporting. So coming on to the environmental stuff, we also can access the data from those environmental devices. And you can see here where we're capturing data from existing devices about emissions, but then turning those into meaningful information. Here's the permitted exposure limits as based by the WHO and OSHA and EU directives. And it shows you what the max was detected and whether that's good. It's also looking here at particulates. Some people think of particulates as dirty old diesel taxis in London, but what they fail to know is that one of the most dangerous and carcinogenic particulates that exists on this planet is printer toner, photocopier toner, which obviously exists in every building. So being able to pick that up and then obviously turn this into an air quality index. I can see here on that date that, it almost got to the point of being very unhealthy. Being able to turn all of this information to actual useful, meaningful information. And also looking at data that doesn't actually come from inside the organization. We can look at external data sources. And in this case here, I'm looking at data for a large, well-known West Country indie band. I won't give you their name. And we can see here all of their movements. And this is just the key band members, their movements by plane and accommodation for 1 month in July 2017. And for each of these flights, now we can see their carbon footprint. If I click on that, it'll actually tell me exactly how many, 437 kilograms of CO2 just to travel from there to there. Going one step further, I mean, we're doing some work at the moment with a large investment bank. What we're getting to there is almost, going right down to this month. Let's just find some data, getting down to starting to log every single system and subsystem within their organization in order to show, things like how many pages of paper have been printed on the local printers, how much electricity has been used, what the personal heating settings are, because they've got a thing called Comfy where each desk can set their own HVAC settings, locker usage. So you can see here we're creating a whole floor plan here of a single floor. So we've created a mechanism again within UCentric where if you've got it in Visio, then we can just import it straight in. But actually, it's just a very simplistic model. So it just uses JSON data, and we create this as part of the pro service engagement with the customer because we can do this in a day, whereas they might spend weeks trying to do it. So, but you sort of get the idea here where we're showing multiple sets of data in one place as well.